Today we're looking at this Sun Microsystems StorEdge S1, a 3-disc storage array from 2001. We're going to pair it up with a very similar looking SunFire V120 server and get them hooked up over Scuzzy. We might even throw a tape drive in the mix. After the Scuzzy cables are all hooked up and the hardware is sorted, we'll hop into the Solaris operating system and set up a RAID array on this thing. Let's get into it. This is a Sun Microsystems StorEdge S1 storage array. Best I can tell, this thing came out in late 2001, and it's an array that can hold 3 Scuzzy hard drives inside of it. If you're familiar with this Sun stuff and thought it was a server, well, I couldn't hold it against you. This is a SunFire V120 from 2002, and obviously, they're very similar. The front bezel on my V120 suffered some unfortunate shipping damage, but place that there, and as you can see, clearly sharing a design language here. Despite being so visually similar, they're not quite the same. So the storage unit has this extra kind of lip over here, and if we slide the server in, we can see the server is not as wide. I have a partial rail kit for the server, and these plastic guys slide on just like that to bring them to the same width. If we stack them on top and take a look from the back, you can see exactly what I'm talking about. They're so similar, like clearly these are the same power supplies, the same little rocker switches, but the server is not as wide, and this is what I was trying to describe earlier. With the rail kit on, same width. This SunFire V120 is the first piece of Sun equipment I ever bought, and what drew me to it was the logo on the front. Of course, obviously Sun is a very important company in the history of computing and especially software, but I love the attention to detail they always put into their hardware. And what drew me to this one was it looks just like this one. I've always been kind of sad about all these scratches the server has into the logo, even though it doesn't really matter. And over here, the storage array is in much better shape logo-wise. Of course, this isn't important, but I'd be lying to you if I told you it wasn't one of the reasons I picked this up. To better illustrate what this thing's all about, we can pop this front bezel off, 2 little tabs, and it kind of hangs down. That's why I have it hanging off the bench here as if it's in a rack. And we clearly have 3 hard drive bays. In the first bay here, we have a seemingly complex diagram about Scuzzy target IDs. So we will first have to understand what Scuzzy is all about before we can make any sense of this thing. But we'll start with a physical overview and get familiar with this unit. So these things use Sun's proprietary hard drive caddy system. Got these like sleds that go on there, and I've got one right here, and it's just going to slide in no problem like that and then lock in there. So if you're picking up this gear, like this one didn't come with any hard drive caddies, for example, that can be a little overwhelming, or a little disappointing, I should say, because these eBayers out there, they think they're pretty proud of these sleds. These drive sleds were a Sun standard across a lot of their equipment in the early 2000s. In fact, here's the server, and I can slide the exact same hard drive into this slot with the same sled system. So if you're picking up some of this Sun gear, you're going to want these sleds to put drives in a reasonable fashion. Like I was saying, you can find them, they're around, but they're kind of expensive. So the ideal case is the equipment you have comes with sleds, but that's pretty uncommon, because when this stuff gets recycled, they're going to rip the drives out, shred them, and they'll probably just throw the sleds away. But there is hope. This is a Scuzzy drive with a 3D printed sled on it. Yes, don't let eBay take advantage of you. I'll put a link in the description to these. I've used them a lot. They work great. They don't have this latching mechanism. It just has this kind of plastic piece that you need to make sure you slide into some slots before you put it in the computer, and you kind of got to wrench on it right here to pull it out, but it's really no big deal. The important part is having this sled piece. And by sheer coincidence, a viewer named Nathan is the guy that made these. He actually sent me this compact drive many months ago, maybe over a year ago. Definitely go check that out. The moral of the story is do not be discouraged to pick up this SunFire gear. If you can't find the sleds, you can 3D print them. According to a 2002 scrape of Sun's website, this thing would have set you back around $2,300 to $4,000 US, depending if you got the 2-drive variant with 18 gig drives, or the 2-drive variant with 36 gig drives, or fully blown out for $4,000, 3 36 gig drives. I can tell this was a 2-drive variant because of a very interesting piece over here. This is quite arguably the most interesting aspect of this thing. A foam insert in the shape of the proprietary Sun rails attached to a 3.5-inch hard drive. Wonder how many of these are left in the world. It's even got the knockout there, of course, for the Scuzzy connector. This would have been for airflow purposes, so these things get really hot. I've messed around with them on a bench by themselves, and that I don't think that's recommended. These expect to be in an enclosure with air flowing past them. I mean, this is a 10,000 RPM drive. That is very fast. And so this would have been in the third bay to prevent air from flowing through it, so that all the air was dedicated to bays 1 and 2, because these things get really hot and they expect air flowing past them. That being said, this might be one of my favorite pieces in my retro computing collection. Like, how bizarre. We'll load this thing up with 2 drives, just so we can leave this thing in here. This thing isn't really capable of much of anything on its own, unless it's hooked up to a computer. That's what we're going to use that SunFire V120 for, which looks just like this unit. It's got 2 screws on the back, 2 screws on the front, some side screws here. Just for the sake of completeness, we're going to open it up and take a look inside at what's going on. I bought this over a year ago, and if I recall, I opened it at that time. I've never powered this on. We'll be learning together if it works. Hopefully it does, otherwise this video won't be very good. I don't know if I have to take this rack ear off, but I'll take it off anyway. So that was like 8 screws. I'll show you what it's like to get in that server later. This is clearly not meant to be serviced, because I'm guessing there's not a lot in here. Yeah, we've got the power supply going into this not too big circuit board here. The 3 enclosures with their connector for the Scuzzy drives. And then this is just Scuzzy stuff, I think, to be able to interface 3 Scuzzy drives at once. And then, of course, the all-important case fans for the drives. Look at all this wasted space. My assumption is that they wanted this form factor to match their other servers and gear and make them rackable, even though these are smaller than typical rack gear stuff. Pretty interesting. Just like, look at all this space in here. It's Sun, so it goes without saying. These are very high quality pieces of metal. Everything is super solid. For comparison, for anyone that's curious, this is the V120 server. It's got a pull handle and 1 screw you take out, and it slides right off, and it of course is a server, not a storage array. I did a video about this over a year ago. When I got it, heatsink was floating around in the case, and if you take a look right here, you can see that nub is all chewed up where it was supposed to connect. So I actually swapped out the connector here so that I could latch onto another part of the socket and kind of fix that up. And that was the only thing that was wrong with this thing. Booted right up. This thing has what's called a Scuzzy controller on it, so we can connect Scuzzy devices like that 3-disc array up to it. So that's what we're going to use this thing for, and it's going to host the software to interface with those drives. I have a bunch of old videos where I kind of go over a few of these SunFire servers. I've been thinking about revisiting them now that I'm a little better at making videos. So yeah, let me know if that's something you'd be interested in. Around back here, I've got the storage on the bottom and the V120 server on the top. And you can see it's got a Scuzzy connector on the server that we're going to use to connect up this storage array. And now it's time to dive into what Scuzzy's all about. So it says LVD/SE. We've got an in and an out here. It says base ID, auto term. We'll figure out what that means. High byte, low byte. Let's do a quick Scuzzy primer. Scuzzy stands for Small Computer System Interface, and it's been around since the early 1980s, and yes, the proper pronunciation is Scuzzy. Scuzzy was derived from the Shugart Associates system interface, Shugart of course being a hardware company that dominated the floppy disk market in the late 1970s. Scuzzy can be confusing, for lack of a better word. There are approximately 5,000 different cable types and numerous iterations of the specification, each with their own slightly similar names. Generally speaking though, you just need to make sure you have the right cables and that your devices can all speak the same signaling language, or how the wires are actually leveraged in the connector. Starting with cables, let me consult my pile on the floor, where I keep my Scuzzy cables for some reason. Found a couple that should work, including this compact branded one. Kind of cool. You can see this tape drive here claims to speak LVD, or low voltage differential signaling. The SunFire also says it speaks LVD. It also speaks SE, which stands for single-ended. That was a signaling type in the very first iteration of Scuzzy, I believe. Generally speaking, LVD and SE can get along, but you do need to worry about making sure your devices can all speak the same signaling language here, and LVD and SE are not the only ones. And I know from the manual that the StorEdge supports LVD. So we'll have a fully LVD chain here. Speaking of chain, at its core, Scuzzy lets you chain together different peripherals back to a computer. Typically hard drives, but also CD-ROMs or tape drives or anything really. And this chain that gets formed is called a bus. That's why the StorEdge has an in and out port, and of course you're seeing that over here on this tape drive. As you can see, we can chain multiple devices together onto the same Scuzzy bus. Each device on the bus has a numeric unique identifier, including the computer. This is the Scuzzy controller, and it uses up one of the IDs. Early iterations of Scuzzy had 8 IDs starting at 0 through 7. Later versions had up to 16. Another important part of the chain or bus is something called termination. On the last item in the bus, you need what's called a terminator. This tells the chain that there's nothing left, and it stops something called reflection, meaning the signal's kind of bouncing back into the one that's sending them, so to speak. A terminator stops that. Some devices are smart enough to auto-terminate, the StorEdge being one of them. That's why we have this auto-term indicator here. It stands for auto-termination. So if this was the last thing in the chain, I wouldn't need to put a physical terminator on there. It's smart enough to stop itself. Speaking of these terminators, these actually were sent in by a generous viewer named TasteWar, and I think we'll use this black one here. You can see it's an LVD/SE terminator, and this light on the back will actually indicate red or green based on which signaling it thinks it's terminating. And TasteWar actually sent in these terminators because they sent me this, an exceedingly rare Scuzzy PC MCIA card for getting Scuzzy peripherals connected up to, a laptop. So we'll definitely have a future video on this. Thank you very much to them. Back to our bus here. A bus is just a shared hardware or software medium that devices can use to communicate, typically back to a CPU. Buses have been around in the software and hardware world well before Scuzzy and are still relevant today, USB or Universal Serial Bus being an easy example. In fact, if we consult the PDP-11 Processor Handbook from 1981, Chapter 2, Unibus, the Unibus was the PDP-11's way of letting multiple peripheral devices connect back to the CPU over a shared line called the Unibus. If you squint pretty hard, it looks a lot like Scuzzy. If you're dealing with a problem at work and you want to sound smart, just start talking about buses. Like, oh yeah, we need a collab bus. You always have to name the bus. We'll need some bus arbitration. We need an arbiter. Don't forget to subscribe for more corporate career tips and tricks. Really though, if you're enjoying this video and you haven't already, please consider subscribing. Keeps me motivated. I have a point here, I promise. A bus concept like the one Scuzzy uses is pretty general, but Scuzzy actually became standardized and very rapidly adopted, hence its success. For example, this IBM Ultrium LTO2 here, which we'll try to get on our Scuzzy bus today. I mean, it was nice for IBM that they didn't need to worry about what this thing would be hooked up to necessarily, just that it adheres to the Scuzzy standard. Like I was saying earlier, every item on the bus needs a unique ID. Sometimes it'll be hard-coded and a device will always be ID 4 or whatever, but most of the time you're gonna have one of these like little dial indicators that lets you actually choose which ID your item is, as is the case with this tape drive here. It's at 0 right now, so if we roll it back the other direction, we of course get to 15, so 0 through 15, a total of 16 items on these later Scuzzy bus iterations. I don't know, we're just gonna throw this on 10 for now. The one on the back of the StorEdge is a little more complicated though. It says base ID, hex, and parentheses, and if we start rolling through this thing, we start getting letters, hexadecimal. Back around to the front of the unit, we've come full circle, hopefully, to this Scuzzy target ID card, and I think we can make some sense of it now. Each of these drives is going to be exposed as an individual drive on the Scuzzy bus. And so this base ID hex rear column is the indicator I was just showing you on the back. I'm going to leave it on 3, meaning the drives will be exposed as Scuzzy ID 3, 4, and 5 on the bus. And if I had put it on the letter A, for example, they would be using Scuzzy IDs 10, 11, and 12. There's also this binary display section, so if we take our 3 example, it says that these right 2 LEDs are going to be illuminated, and that corresponds to this thing. So when 3 is set on the back, these right 2 are going to be illuminated, apparently, so that at a glance, I guess, I can look at this. And this little diagram kind of outlines all that. So 3, 2 right LEDs, 3, 4, 5 IDs on the Scuzzy bus. A little involved, and this is in the documentation, so you don't actually have to pull this out every time, presumably, if you're using these in production. But I guess, we can at least make sense of it now that we've gone over Scuzzy and these IDs. That's kind of why I did all that. The next thing to do is get a couple of drives in this thing. So I already have a few of these 146 gig Sun drives in their sleds here. but in my experience, that old V120 does not like formatting these. It takes like over 24 hours for these huge drives. So I'm going to swap in these compact 36 gig drives. That's actually more appropriate for what this would have shipped with. I think 36 gigs was what they quoted as the maximum, though I doubt it matters. So I'm going to swap these sleds around real quick. That's pretty nasty. Had to clean these compact drives up a little bit. It's always really cool seeing compact branded stuff because they've been gone for so long. These came out of a HP DL380 Gen 3 from the early 2000s I've got. And I'm pretty sure that was a RAID array, so that's not going to work anymore. Okay, I think we're ready. Kind of looks a little sacrilege, but we're working with what we got. The enclosure itself seems to imply that Fujitsu drives might have been a little more appropriate. Here's our first one. I always forget to pop that out before I'm jamming these into a machine. And there's two. I think we can get this back in place. I think that's the StorEdge all sorted for now. And next, we need to dive into this V120 to actually interface and use the StorEdge in a meaningful way. And in order for any of that to make sense, we must first learn about the Sun Microsystems Lights Out Management. On the back of the unit, we've got this LOM port, stands for Lights Out Management. It looks like a network interface port, but it's actually a serial port. And in fact, you can use the blue Cisco cables that you might be familiar with to hook it up to a computer's serial port here. And this lets us access the LOM. It's sort of a computer inside this computer. When this thing is plugged in, even if it's not powered on, so I can get it plugged into the wall, but you won't hear any fans or anything. It's actually powering that little chip, the LOM, and we can access and remotely manage this thing over a serial console and do some sort of rudimentary checks of it. Let's do just that. Got it wired up here. There's a few different components in the management machinery of these SunFire systems, and it's by far the most fascinating aspect of them. The first component, of course, is what I've been talking about, the LOM. It's a computer in this computer. The next level is something called the OpenBoot prom, also known as the OK prompt because it's literally an OK prompt. That's sort of a configuration environment for the server, and it actually has to be powered up to get into that one. You can think of it sort of like a BIOS, I guess. And then, of course, finally, you can boot into a real system. So we're going to explore all that. First, the LOM. It's kind of like the lowest management mechanism. Now, one of two things is going to happen here. I'm going to give this thing power, and what I hope happens is nothing, which means we're just booting into the LOM. But it's possible that this thing's going to rip right up and try to boot into the OS. It does that sometimes, so let's see what happens. Flip it on here. Nothing. Okay. So here over the serial console, we're at the LOM. The machine has power from the wall, but it's not on. It's just that LOM chip is running and we can interact with it over the console. So I just issued an environment command. It tells you a little bit about what it thinks is going on. Everything's in standby, so all the power rails, if we scroll up, we can see it's got 2 fans, 1 CPU, 1 PSU. It thinks everything's okay, but of course everything's in standby. There's no power going to these things. It also thinks the enclosure is at 23 degrees Celsius, apparently. And if I type help, you can see there's all sorts of commands about stuff we can do, including powering the machine up. We'll do that shortly. When we power on the SunFire from the LOM, one of 2 paths can be followed. We can land directly into something called the OK prompt. This, again, can be thought of as sort of like the BIOS, or it'll progress past that and go right into the operating system if one is on a boot disk. What I'd like to do is go into the OK prompt to show you guys around, and in order to do that, we need to set the boot mode. So right here, I've got boot mode normal. If I issue that, it shows me what the boot mode is currently set to. Normal means just go right to the OS. If you have a boot disk and there's an OS on it, boot into it. What we're gonna do is issue a boot mode 4th, and this will tell it to get into the OK prompt and halt before it bothers booting an OS, and we can go further from there if we wish. You set it to boot mode 4th because the language used to write the OK prompt firmware is in the 4th system language. A little bit of like your implementation leaking into your API details, but that's okay. Just to double check, we can say boot mode, we're in 4th. Here is a diagram from Sun, maybe not their best work, showing all these different prompts you can hop to. So we're in the LOM right here, and we're going to be able to issue a power on command, and we're going to be able to hop over into the OK prompt. Up top, that top of the triangle here represents the operating system actually running, and I'll show this diagram again as we start messing around. So I'm going to issue a power on, and that thing's actually going to rip up, and I suspect you're going to hear it. There we go. So now it's actually booting the machine. It's actually running the CPU and able to use memory and things like that. The OK prompt environment actually requires the CPU to be running. We'll be able to do things like probe Scuzzy devices, all sorts of interesting stuff. So we'll let this do its thing, and I'll show you around. A few moments later, it's up, and as you can see, it's literally an OK prompt. And it even has a nice little message, aborting startup sequence because of LOM boot mode 4th. So that's what hopped us in here and stopped it from booting to the OS that's actually on a disk in there. That diagram I was showing you with the LOM and the OK prompt, we can move between these prompts. So if I do pound dot, you can see I'm back at the LOM, and if I type console, I'm back at the OK prompt. So I can move between them as needed. Once we boot out of this OK prompt into an OS though, I can't hop back to here. I can get to the LOM because it's a totally separate computer, but you either have the OK prompt or the OS that's actually running. What I'm saying here isn't entirely true. You can actually get from the OS to the OK prompt by halting the OS with stop A. So on Sun keyboards, they had a stop key. Stop A would have been the combination to halt and actually get back to the OK prompt. I think it's like control break on other keyboards. So you can indeed go from the OK prompt to an OS, but the OS actually has to halt entirely, so only one can run at a time. Special thanks to Krebs over on Patreon for pointing that out to me. Now, my top favorite OK prompt command is probe Scuzzy. This is going to go off and actually see all the Scuzzy devices it can find that are connected to it. And right away, we of course get the hard drive that's actually in the front of the machine. It happens to be Scuzzy as well. And then it's not going to find anything else. So let's fire up the StorEdge, get it all connected, and do another probe Scuzzy and see what we get. But for the sake of my ears, in the meantime, I'm going to power it off. So hop back to the LOM, and we can say power off. Got the basic configuration here. Power ready to go into both units, and then the Scuzzy controller on the V120 hooked into the input of the storage controller. I don't think anything will happen. Good. Now let's power up the StorEdge. It turns on. That's exciting. I believe what we're seeing here is it has claimed that it has auto-terminated itself, which would be the right behavior in this setup. LEDs on the front panel are telling me it knows it's got 2 hard drives, another good sign. Let's see if I can slide this off while it's flat on the bench like this. Aha, and then hopefully you can see in there. Those are the hard drive indicators, but these base ID binary lights, remember the right 2 should be illuminated, which does mean we're using Scuzzy ID 3, 4, and 5 on these drives. So that's all looking as expected so far. And my boot mode didn't get persisted, so I'll say boot mode 4th. And now let's power this thing on and try another probe Scuzzy. Hopefully we see some more stuff. Takes it quite a while to ECC test its pretty generous 1 gig of RAM, I believe, is in there. Yeah. Okay, we are at the OK prompt. Let's do a probe Scuzzy. Sometimes it's complaining that you might not get the right results. Let's do it anyway. So yeah, if it hops right to this OK prompt without actually probing the Scuzzy devices, you have to do a reset all. I'm not sure why I need to do that in a fresh restart like this, because this just happened, but yeah, let me know if you know. A reset all, basically like a reboot, and hopefully we see some Scuzzy stuff, because we know there's at least the one disk. Okay, probe Scuzzy. Maybe probe Scuzzy doesn't actually look on the chain I've got set up. I'm trying to probe Scuzzy all. Oh, look at that. Those are our compact disks. So the internal probe Scuzzy command must just be looking for the 2 drive bays in the server itself. I switched to this probe Scuzzy all command, and yeah, look at that. This is the internal Scuzzy controller that goes out the back that our cables are plugged into, and we can see 2 compact disks, so we can interact with the StorEdge, and it's probably working well, at least so far. Well, now I'm getting greedy. Let's hook this tape drive up. Found this big old thing to hopefully make that a little more ergonomic. These Scuzzy cables are just chonkers because there's like 68 pins in there or whatever. So let's see, I'm gonna put the Scuzzy cable here, and then we'll get our terminator. Put that right here, I guess. We'll get hooked up to the output of the StorEdge. I'm having too much fun. This is good. This is too good. So that's going to be the setup here. I'm actually going to screw this in, even though I don't believe in that. It's for cowards. But this cable is quite the troublemaker. There's the setup. I'll show you what this thing does when we power it up. I'm going to power it up first. We're not going to go any further than that. I'd kind of like to do a full video on this thing. I actually bought some new old stock Ultrium 2 200 gig tapes. So let me know if that's something you'd be interested in. I think it'd be fun to explore. It's quite the beefy unit. Not entirely sure how well that green screen is going to show up on camera, but we'll power it on here. Does a little beep and a self-test. My hunch is that this little segment is going to tell us what Scuzzy ID it is, but maybe not. All right, Ultrium tape drive empty, and this doesn't tell us anything, so that must be related to when it's actually, you know, the mechanism's actually doing something. I have no idea if I can even use this with the SunFires, but what we really want to see is this show up on our Scuzzy bus in the probe Scuzzy, so I'm going to power these other two guys back on. And in this configuration on the back here, we have this high byte, low byte stuff in the auto termination indicator section. There's a table in the documentation that tells you the different combinations of those lights being on and off and what they mean. Basically, both of them off, it knows it's the first thing in a Scuzzy chain and that there's a device coming after it, which is the tape drive here. Big old Scuzzy cables have a very distinct, like, chemical smell. Anyway, it smells like serious business down here. Back at the OK prompt, we're going to do another probe Scuzzy all. So target 3 and 4, remember we were using Scuzzy IDs 3, 4, and 5 on that disk, so that makes sense. Look at that! I don't know what target A is. Oh, it's in hex. It's in hex, so 10. A is 10 in hex, which is what we set on the back of that unit. Removable tape from IBM, it knows. Scuzzy. Standardizations. Gotta love it. This is awesome. I'm loving this setup. Look at these cables. Got everything powered off. We're going to say goodbye to our tape friend here. He will make a return in another video. Really cool to see that show up in the probe Scuzzy. Very excited that this might actually be something I can use and have fun with. I'm going to get these two guys in another room. They're awfully loud. And then we'll actually boot into Solaris. That's the Unix variant from Sun that's actually running on this, the hard drive that's in this V120 server. Then we'll actually try to do something interesting with the disks in the array. Maybe get a ZFS pool, or at least put some files on them and make sure the disks are healthy, and kind of convince ourselves that this disk array is truly actually working the way we expect. Before I move this to the other room, let's see if we can't do anything about this stupid sticker on the front of it. Good as new. Pretty smart looking couple. Both of those machines are on top of the rack in a different room, and in fact I'm powering them over an extension cord, because when you turn each of these on, there is so much inrush current that it flips the GFCI outlet that the whole rack is plugged into, which powers down my entire network because only the servers are on battery backup. That's been a fun experience. It's happened twice now. We're back at the OK prompt now. The machine is powered on, and if you remember our cursed Sun Microsystems triangle of death, we know how to get from the LOM to the OK prompt, and now we're finally going to boot in an OS that's on the single disk in that V120 server. Solaris. Solaris is Sun's Unix variant, which would have been running on these machines back in the day. At the OK prompt, we're going to issue a boot command, and we're going to give it the -R flag, which stands for reconfigure. What this is going to do is tell Solaris to go look for new peripherals, the disk array with the 2 drives in it in our case, and make sure they're all set up and that we have access to them once the OS boots up. So you can see it already knows that this disk in the front of the machine there is the boot device that's been pre-configured, and it's going to go off and boot us up into Solaris, and we'll actually be using an operating system, finally, on this machine. While that's happening, let's talk about the software side of things. These StorEdge units would have shipped with something called the Storage Subsystem Manager, but I can't find a copy of this anywhere at all, and as far as I can tell, at least for now, it's been lost to time. This was actually one of the reasons I had put off messing with this thing for so long, because I thought I was going to need the software to interact with it, and I didn't realize it was just going to expose the 3 disks over the Scuzzy bus. And over on Instagram, a viewer named Jeff, who actually used to be a Sun sales engineer, mentioned something called the Solstice Disk Suite. Solstice Disk Suite used to be a paid-for add-on to Solaris you could buy in the 1990s. But as of Solaris 8 in the year 2000s, which is contemporary with the machines we're using here, it was renamed to the Solaris Volume Manager and integrated directly into Solaris releases. So you can see it's configuring devices, and it's unhappy with device 3 and 4, our Scuzzy IDs. It's actually quite convenient to know the Scuzzy IDs. But that's okay. We're going to format these and get them ready. The plan here is to create a RAID 0 array with Solaris Volume Manager using those 2 disks. Okay, let's get logged in here and see if I remember my information. This is Sun OS 5.10, aka Solaris 10, which is way too new for this poor machine, and it really struggles with it, but we'll be all right. And I think what we want to do is the format command, and hopefully it can find all the disks, and it does. This is a relief to me anyway. Solaris uses some pretty interesting disk names if you're coming from like the Linux or especially the Microsoft world. Maybe this is a Unix thing. You can see the first part is the controller they're on. So this is the internal disk that's actually hosting Solaris that we're running here. These two disks are the disk array on the Scuzzy bus. They're on a different controller. You can see there's C1. This T3 means it's Scuzzy ID 3, T4, Scuzzy ID 4. So we're gonna go in and format number 1. The disk is not labeled. Every disk needs a label, I believe. We'll say yes. And we're gonna do partition, I think. Modify. I can't remember what to do. I'm gonna go do some research. Actually, very exciting new plan. We're just gonna raw dog it right into Solaris Volume Manager, which I've never used before, and see if it works. First thing we're gonna do is create some state database replicas. These are little bits of information on the drives that SVM, the Solaris Volume Manager, uses to understand the configuration of them, or something like that, I guess. We do that with the metadb command, and we point it at the first disk. And you'll notice, when we were looking at the disk names before, they just had this part, the controller, the Scuzzy ID, and the drive number. Now I've got this S7 thing going on here. Well, Solaris calls drive partitions slices, and each slice has a number assigned to it, and they're used traditionally for different purposes. In our case, slice 7 on a drive is used for these metadb configuration databases, is my understanding. So let's let it rip. Oh my God. Oh no. Device size 0 too small for database replica. So it begins. If you were a Solaris administrator, look away now, because I'm winging it. I have altered the partition number 7. We care about slice 7 in this case. It was 0. This is the first drive, ID 3 in the array, and I'm liking that. So let's go back to format, and I'll show you what I did here. So let's do the second drive. I know this is kind of confusing. The first drive is what I've been calling Scuzzy ID 3, and the second one is Scuzzy ID 4, but I'm just looking at the first and second drive in the array, sorry. We're gonna go to partition, and let's do a modify. We're gonna modify the existing partition table. So you can see, this is how these disks were set up at first, with slice 7 having no size to it. We need at least a few megabytes in that slice for the database configuration, is my understanding. And I'm not gonna change anything else, so I'm just ignoring all these until I get to 7, and I am pretty arbitrarily giving it 6 megabytes. And we'll say yes. Give it a name. Let's try our metadb command again. If this doesn't work, I promise I will actually go and research this and figure out what to do, and then I'll come back. Oh, I think it succeeded. We need to create a DB on the other disk. So far, so good. Now we need to actually like initialize the RAID. So we use meta init for this. We're going to create something called D0, a virtual device 0, which is going to be the combination of those two drives together. One stripe, some RAID terminology, 2 items in it, and it's these 2 disks. Now, initially here, this is 30 minutes in the future from what you just saw, by the way. Initially here, I had pointed it at slice 2, and I'll show you what it does. It doesn't like it and says overlaps with device and meta device state database. If we go back to format, and we take a look at our partition table, I think slice 2 is traditionally the entire disk, so I kind of just naively thought, okay, yeah, I'll use both disks. But you can see it uses the entire disk, cylinders 0 through 13999. And I think that's what it's complaining about. It's saying you're trying to RAID over the database, which is in this range. So the database is from 13,997 to 13,999, the end of the disk. And this encompasses that. And I think metadb doesn't like this. So what I'm going to actually do is use slice 6 here, which you can see is everything before the DB. Clear as day, right? Well, let's try meta init again with slice 6. Ooh, that's good news. We can do a meta stat D0. Oh, baby. Look at that. So we have a virtual RAID 0 device, 67 gigabytes. So both of those drives added together. Let's see if we can like mount it and put something on it. Okay, I think we want to use new FS to create a file system on this thing. Yes. Not sure how long this is going to take. It is initializing the cylinder groups. Looks like it's done. So let's make a folder to mount this thing on. Mount, call it StorEdge. And then we'll mount that disk in our new folder. And we're going to go into it maybe. Well, forgot how to use computers. We have a fully functional, roughly 60 gig disk array. As one final look, I think we can do DFH to look at all our file systems, and there it is, 67 gigs at Mount StorEdge. Just like that. That was pretty cool. And I didn't even need to open this thing up. I almost forgot to show you. We can get to the LOM from Solaris, so pound dot. Check that out. We're at the LOM prompt because they're two totally different machines. We can't get to the OK prompt, as I recall. Console, remember, took us to the OK prompt before. Now it just hops us back in Solaris. Just another oddity, sort of another fun thing about this SunFire ecosystem. So what is the plan for all this stuff? Well, I'd like to run something called a Sun cluster, which lets multiple physical SunFires get together and run in a clustered OS environment via Solaris. Ideally, I would find one or more V120s to use in the cluster, and I'd use this StorEdge as sort of an era-appropriate database and storage backing. But if I can't find another one of these, I've got more SunFires we can kind of mix and match into a Sun cluster eventually. This went a lot smoother than I thought it was going to. This Solaris stuff can sometimes be quite the journey. But I'm thrilled that this StorEdge S1 works. It's been sitting on my shelf staring at me for quite some time, so I'm very happy to see it spin up. My apologies if the Solaris Volume Manager and the RAID stuff was kind of boring, but that is how someone would have, administered these back in the day, so that was pretty cool to get set up. If you made it this far, thank you so much for watching, and if you haven't already, please consider subscribing. Helps the channel grow. And if you'd really like to support all these old computers and networking gear down here, I'm on Patreon. I post behind-the-scenes type footage, and generally what I'm thinking about down here. Thanks once again for joining me on this journey. I hope I see you in the next one.